Esma from Chemistry Department. This video will be about my Physics 101 lab project. The experiment's objective is to investigate the relation between the masses of the objects and travel time on an inclined plane.
This experiment will focus on the relation between the mass and the travel time of an object on an inclined plane. This project aims to experimentally justify the claim that the mass has no correlation with travel time. So let's continue with the theoretical parts. We will use kinematic equations and Newton's laws of motion for this free-form object. As you can see from diagram 1, the object's downmost corner will be the origin of our reference frame. The inclined plane is the x-axis and the y-axis will be perpendicular to the plane, and it will also pass the origin. For this experiment, our initial velocity and our initial position is 0, as seen in diagram 1. Therefore, our velocity of a function of t is equal to acceleration times time, and x of a function of t equals to 1/2 times acceleration times time squared plus some constant, but we said that the initial position is 0, so some constant is 0. Our final equation will be like this. Let's continue with the diagram 2. It shows that object on an inclined plane and it's free body diagram. In this experiment, since the object is balanced on the y-axis, we know that normal force is equal to y component of the weights, and by using Newton's second law of motion, that F net equals to ma, F net equals to x component of weights in this experiment, and when we simplify it on both sides, we acknowledge that our acceleration in that experiment equals to times sine theta, mass substituting g times sine theta to the place of a in the equation 1. We acknowledge that f of a function of t equals to 1/2 times g times sine theta times t squared. Now, let's see how our experimental results align with these predictions. The setup consists of an inclined plane and 5 objects with different masses, as you can see. Now, let's continue with the experiment videos. While you are watching my experiment videos, I will talk about my procedure and potential error sources. These 5 objects with different masses are dropped onto the inclined plane from the same height, which is measured as approximately 37 centimeters. Each of them is repeated 3 times to measure the travel time more precisely and accurately. Let's continue with the possible sources of error. First, the measurement of the length and objects' masses could have some errors because of the limited precision of the ruler and the balance used. Additionally, inaccuracies in the measurement of the inclined angle due to limited precision of slope measuring devices may alter the expected outcomes. Air resistance is another important variable, especially when dealing with smaller masses. Moreover, variations in the inclined plane surface characteristics, such as its irregularities or friction, could introduce systematic errors. In this experiment, friction, I think, the most powerful error source. Besides, the release mechanism for the masses must be carefully calibrated to guarantee simultaneous and consistent release for each trial. There was no automatic mechanism for releasing masses, therefore there can be some errors because of the experimenter and lack of coordination skills. Okay, let's continue with the data and results part. These are the time results that I obtained when I dropped objects of 5 different masses from the inclined plane. Data is recorded in 3 columns. These contains number of the experiment, mass of the free-falling object, and the object's travel time. Average travel time measured is calculated by using the previous table. A graph of mass of the objects and average travel time measured using the data on the previous table. Best fit line of the points is drawn. A linear arrangement of data points is seen in this graph. Expected travel time is calculated according to kinematic equations and Newton's second law in the theory section. And this is my theoretical travel time comparison of the measured at the theoretical data. You can see the difference from this table, and the average of the errors is approximately 49%. In conclusion, this experiment showed that there is no correlation between mass and travel time of objects on an inclined plane.